All right. I think we have a quorum. Thank you all for coming to this largely discussion section on bootstrapping photometric calibrations. My name's Eli Rykoff. I am now Rubin calibration scientist. So what is the question that uh, I want your help in answering? I'm here to ask you for help. Um, So how do we do the initial photometric calibration? So we have plans for self-calibration for full data release, production releases. In later years, year 2, we can use the previous release as a dense network of reference stars in the LSST system. It's going to be awesome. Same thing with templates. It's the same thing. Second year on, easy peasy. But what do we do during first light and commissioning for photometric calibration during the image processing? So we need to know on day 1 what the 0 point is. We need to understand if the throughput of the system is close to what we expect. And that is something that we will be expecting as soon as we have in focus stars. So maybe not day 1. Day 1, I don't think the focus will be perfect. I apologize to the engineers. But as soon as we can, we need to know what the 0 point is. And so this is one of these interesting problems that is like, we need to know it now, and then a bunch of this work we can just chuck out the door, but we need to know it ahead of time. So for the initial photometric calibration, we do not need 5 millimag precision. That's a good thing. We would not get this from 1 0 point per detector anyway. You're not going to get that precision. How much can the residuals vary over the detector? This is just a random question, but is 5% good enough? 2%, 1%? On day 1, I think that 5% will probably be fine. We'll be excited if we, know our throughputs that well. But on day n-1, we'll want better. And at the end of commissioning, we should be able to use previous calibrated stars as a reference. So roughly emulating what we'll do after first year of observations. But there's still the... Yes, Robert. I'm saying you, Grizzy. The whole thing. I'll get to that. So, yes, exactly. How good is... Compared to what? We'll get to that in a moment. So there is... So, so what will we be calibrating? The commissioning observing strategy has not been finalized. We'll have ComCam first, so we'll need to know this with ComCam, followed by LSST cam. We don't know exactly, the schedules have changed. There'll be different fields for ComCam and LSST cam if LSST cam follows 6 months later. The stupid sun. Yes. Okay, not entirely, but I don't think we're only going to be observing circumpolar, I assume. But you're right, there are some spots that we should observe with both cameras, but we will want a range of air masses and whatnot with both. So necessarily there will be divergence. Oh, yes. The question was, what about circumpolar observations, which will be up all year round? And so there will be, a field, some fields that we can observe with both ComCam and LSST cam, and we should definitely do that. So as Keith introduced the other day, it will be something like 3 fields with mini surveys to LSST 20-year depth, one of the DDF fields, an ecliptic field, a dense stellar field probably. That'll be fun. No, I'm saying these mini surveys are either 4 or 7 pointings or whatever. This was in Keith's session from the other day. Am I right, Keith? Yeah. Yeah, Keith is saying it's a few disconnected regions on the sky. So when I say a field, I mean more than one pointing for these little dithered mini surveys. And they'll have different dithering strategies, and exactly what that is TBD. Željko, and you can stand up and use the mic.
Given that we use field of view in numerous publications, calling this region would be perhaps better.
Excellent. Okay. I 3 regions. Excuse me. Which regions chosen will depend on the commissioning season. There's Cosmos, if possible. Other observations, I believe that there's an agreement to do the Euclid South, Keith said. Is that, or it's a possibility. And observations, as answering Robert's question from earlier, in all of U, G, R, I, Z, and Y. So the key questions that I have, we open the shutter for the first time in focus. What is the 0 point? This is the bootstrap problem. Other question, what are the best 0 points during commissioning? This should be handled by standard DRP processing, including FGCM global calibration. This should be, at the end of commissioning, we are commissioning all of the software as well. The reference stars are not required for relative calibration. Something is required for absolute calibration. And of course, the final point, how to verify our photometry. Repeatability can be done internally, but we will need to compare it to some external references to evaluate uniformity and our absolute calibration. And Gaia is likely for this. I have more slides on Gaia in a moment. So some reference catalog options. Up until now, we've been using PanStars 1 for HSC. Good density of stars, decent enough uniformity, good uniformity. Covers GRIZY, though Y is a bit dicey. And where's U? Where are you? And it only goes down to minus 30 degrees declination, so that certainly won't help us with our circumpolar fields. DES, 2 millimag uniformity over GRIZY. Again, problem with U. A dense network of reference stars, and covers only a portion of the southern sky. So we are not going to be solely observing during commissioning where DES observed. There's the DELV survey. This is DCAM heterogeneous observations in GRIZ, all the way to plus 30 degrees declination. Here's a map of what's been observed so far. You could use these stars as a reference, and they have worked, and you can go to that link and Peter, where's Peter? There you are. Peter has done the hard work on doing calibrations, and even if we don't use DELV, they have extensive experience with RefCrats over the south, combining PanStars and SkyMapper and relative calibration offsets between there, which are a lot of fun. Again, and then SkyMapper, there's the 1% calibration shift. Now that is not catastrophic for bootstrapping calibrations. So, and Delve is figuring this out. So maybe that's the easy option. But what's that? Yeah.
There's bands around the 4,000 angstrom break. Do they have a U band? I don't remember.
No. So this is my next. So what about you? I'm getting to that. So we don't have a lot of U-band survey observations, unfortunately. Just ask Doug here, who has spent a lot of time calibrating the U-band for the deep fields for DES. We could rely on color terms from GRI with a specific subset of stars. How well do we need to do this? Transformation is metallicity and position dependent, which is unpleasant. But the final requirements is 20 millimag uniformity in U, 10 millimag for colors including U. So we don't, and for the bootstrapped calibrations, maybe 10% is fine. Can we do 10% with a subset of stars? Doug says yes. So maybe that's the answer and do a GRI transformation. But as Peter was asking, there's another option, which is Gaia DR3. In particular, the galaxy in your preferred colors as the paper. They have low-resolution spectrophotometry. This they call the XP spectra from the BP and RP channels. 220 million stars around the sky. The majority, vast majority, are brighter than 17.65, but with a tail going fainter. Wavelength coverage, 330 to 1050. This is, this gets us something in our U-band. And they have some software provided to convert to different surveys. And they include transformations to broadband systems, including PS1, DCAM, etc. There are some caveats, though. This is on the left panel. This is from the Montegrifo paper. I didn't put that down there. I apologize. This is a comparison of the raw synthetic photometry to SDSS GRIZ to real SDSS GRIZ. You can see there's absolute offsets at the bright end and significant background issues causing curvature to the faint end. And you can't see the units on this screen, but the curvature goes down to about, let's see, 0.1 mags, so 10% for the fainter ones. Yeah, okay, so yes. The left panel going down, the raw synthetic magnitudes. Then they have this procedure, which they call standardization with an S. And it's basically an empirical global fix to the background and the offsets. So there's a little bit more to it, but it's essentially a global background term, absolute offset. And after they do the standardization, GRIZ, it looks really good. But this is an empirical correction, and you don't have this right away to the LSST cam. And it also, so uncorrected values are good to about 5% at G brighter than 17.5, which is where most of the stars are. So that's the other caveat. They did one global correction, and they said there's probably spatial structure. In fact, I know that there will be, and it will be density dependent, and they do not have any of that in there. Julian. Can you use the mic? Apologies.
So for DAISY, we have standard stars, and we are selecting them in magnitude, and then we are observing them with spectroscopy, and then we are comparing them with stellar models, and we're able to predict from the stellar models the G minus R color to better than 2% RMS. So it means that you could take that stellar model, and then that's a predictor from a kind of accurate U-band. So,
okay.
So what I mean is that, I don't know, it's just an idea. I haven't thought more about it, but there could be a program where from G and R observed, we would target some of those stars for spectroscopy and then get a pretty good prediction for what their U-band. Yeah, We should look into that. I'm just saying it's a possibility.
Yeah,
could think about.
and I think
I'm a little bit confident because of this G minus R prediction of better than 2%.
mm-hmm. and I believe it will work for a subset of stars at higher galactic latitude. It's when you start going into the disk of the Milky Way and the population's quite different. At least what I've seen, it, those transformations change by definitely more than 2%. So anyway, so you could start with these if you could, and it's good to 5%, which is good enough for the bootstrapping kind of thing, except is the density high enough? That's one of the questions. Good news is it's easier in LSST than HSC because shorter exposures and a brighter saturation magnitude than HSC. So you have more of those stars in there. But just as a baseline, I looked at DC2 IMSIM data as part of DP 0.2, and brighter than 17.5 or something that aren't saturated, we're looking at typically 10 to 20 stars per detector, and as few as 2 to 3. So it varies, and that's at high galactic latitude. If you go to lower galactic latitude, of course, you'll get more. So at least that part is easier at lower galactic latitude. It's plenty per visit, if not detector per visit. I had another slide with more details about that. The science pipelines is not currently set up to do per detector, per visit, 189 detector, initial 0 points. Do we need to? We were planning on writing kind of a mop-up thing, but for alert processing, you really need to get each detector moving through on its own. If we think that 10 stars is enough, get us most of the focal plane most of the time. Initially we could use the synthetic decam fluxes or something else, and our own synthetic color terms, or just use the unstandardized ones at first and get 5%. 100% sure this will be absolutely fantastic answering the question of how do we validate our uniformity after a suitable standardization procedure at the end of commissioning. Plenty of stars for that. It's just not quite enough, I think, to be comfortable for the initial bootstrapped ones. And that is all my slides. And then I wanted to open it up for you to tell me, oh, I didn't know about something. It's actually, the U-band is really easy because, as Julian said, we can just leverage the density spectroscopy and synthesize it. But all sorts of, Douglas? And then Eric, and then Jelko.
So one possibility, this might require a slight two-step process, but for the DES heat fields, I've been using Galax, the Galax NUV plus Gaia EDR3, get results that are about when I compare with when I try to recalibrate SDSS G-band over the SDSS area, I get about 2.5% errors. And this does require, however, a galactic latitude correction.
Mm-hmm.
It's a very simple galactic latitude correction. Another caveat is that Galax NUV is although it's code all sky, is kind of patchy. So that's why you're going to need a second iteration where first you tie things to data which do have Galax overlap, but then you need to. So
you would say use something like, let's say, Delve or something that has a broad coverage in the south, or even Pan-STARRS and SkyMapper, and do this Galax predict U kind of thing, and then you'll get a pseudo U of sufficient density.
Galax, of course, is.
Well, that's
2700.
Is that enough without having a U-band in the south? Is that enough? Okay. Yeah, how big is the Galax beam?
Oh yeah, I don't quite remember. It is not. Ours.
Thank you. I had not considered that.
Other RefCAD options?
This is Eric Dennehy,
Yeah,
by the way.
Have you looked at the VST Atlas catalog?
I have not.
So this is the Vista Survey Telescope at Paranal. They've done a UGRIZ over 4,500 square degrees in the south. And the U-band is fairly similar to the SDSS U-band, and there's plenty of calibration papers that have shown comparisons.
Okay.
If we get lucky and we're in the right part of the sky, I think we could have pretty significant U-band depth in that overlapping region.
Okay, thanks. So the over 4,500 square degrees, there's the U-band. Okay. And Jelko has a...
Don't see all the heads. Is Lobra Palaversa here? No. Okay, I'll report instead of him. He showed me yesterday in...
Who is this?
Lobra Palaversa. He's one of international contributors. He's from Ruđer Bošković Institute in Zagreb, and he's Gaia collaboration member. So he took this XP spectra, and you can show that there is enough wavelength resolution in this spectra that you can choose the best fitting Kurutz model that is consistent with this spectra. And that allows you, that automatically gives you the correct log G and especially metallicity. And that allows you to extrapolate a little bit into U-band and Y-band and generate LSST magnitudes for all those 200 million stars that they have. So he said they'll have this catalog in maybe a month or two.
Oh, wonderful. Yeah, so I actually was, and in the paper there is U-band studies and whatnot. So I think that the Gaia as a validator of the U-band, and maybe with, their additional work, is absolutely the answer to that question. It's just, is the density enough to get us, on day one? Robert.
I mean, on the Gaia spectrum, it wasn't designed to do this. They haven't been terribly careful about their 2D PSFs as they get out into the wings. It's a grism. So I suspect we're going to find worse things, scan line to scan line variations in Gaia, and that once we push below 2%, up to 3%, we're going to find we're doing an awful lot of work for the Gaia collaboration, especially at you.
So outside of you, what I have not had a chance to do before this meeting is take the DS standard stars, which I've compared extensively to Gaia G, and how DR2 is much better than DR1 in those. BPRP already had, noticeable scan lines, but I'm going to run through with the synthetic photometry.
Given this discussion, I want to ask the following question just to be sure that I understand correctly. From your first slides, I got the impression that you still plan to have self-calibration of LSST photometry. We'll do some raster scans. We'll have overlap. We will solve in each band for intrinsic calibration. And then the only thing we don't know per band is just one number, how to go from that intrinsic scale to absolute scale.
Yes.
So Robert's comment about Gaia will have its intrinsic problems, that's true, but we just need one number, so we can just define it, say, as median.
It's what we really also want, and what we used it for in DES is to validate that we do have good uniformity.
Right, but bottom line, we don't have to debug Gaia.
No, right.
I'm not sure I totally agree with that.
Okay.
There may be spatial structure in the Gaia data which we are unable to pull out ourselves. And I think it's a little simplistic to say all we need is FGCM and it's going to have no spatial structures left over, and we can just demonstrate that against Gaia. And then we're going to have problems. We're going to have to sort them out. It's not the one overall number. It's the understanding what happens as we get down into the plane and the crowding goes up and the conditions get worse.
And the backgrounds get harder and all the
Yeah.
wings of the neighboring stars and all the wonderfulness.
Yeah, right. So I don't quite agree that. No, you answer the different.
And right now I'm not talking about getting down to millimag levels. We're not ready for that on year one.
I wanted to ask about scope. This is called bootstrapping, photometric calibration. You talked about commissioning. I kind of feel like we're also talking about what we really want to do for the survey.
That's a really good, my slides got away. I'm thinking about commissioning because holy cow, commissioning is coming up a lot sooner than any of us expect. And if my stuff isn't ready, then I'm in trouble. I don't want to be the tall pole. But this is also something that we do need for the first year. So it isn't just specific fields that we'll be able to think about. We'll need coverage over the whole thing. And then once we get through the first year, that we can use our own stars for subsequent observations.
Okay, I was trying to ask if you wanted to help, if you wanted to focus the discussion to be just about commissioning.
No, the first year is, thank you for bringing, that was absolutely on the remit, and then I got trapped in.
Right, and I asked that in part because if you just have a few fields, then all these questions are sort of an issue. About the year now, you can start to do all that stuff, and I guess my general question is very simplistic. 5% seems enough that you can iterate it pretty good. Factor of, you understand, like 100% is probably wrong. You may not find the right space. Is it useful, or do you have a vision? I mean, you should actually have some sense of how close do you have to be such that you can iterate and compare.
So in terms of what you need to know for the FGCM solution, you don't need to know anything. I mean, if you know the general throughput that will have some estimate, it'll dead reckon it. And with DES, we got within 5-10% using the dead reckoning, based on like some observations of BD17 that Doug had done like during commissioning. I mean, and then just put that number and it's like, it works. So that doesn't get you to the absolute calibration required numbers, but you don't need to know these, but you do need to know as you're performing the survey, through the commissioning in the first year, what is our performance? These metrics need to show up on the dashboard. The alert processing needs to know to some level, and you need, has something gone catastrophically wrong? Like, why did our throughput just drop? And, there's a cloud.
Right. So just to expand upon what Eli is saying, I think there's 3 use cases that we need to consider. One is the 0 point that you obtain with just, per visit, per detector, the real-time performance monitoring, right? That's what Eli was just describing. There's a second use case, which is obtaining the internal, I'll just call it the Rubin-derived photometric calibration, right? What is going into producing the data release, right? And the data release here could mean like an actual year-one data release, but it could also mean sort of an internal, coherently processed data set that we're using during commissioning. And then there's a third use case, which is the verification validation, right? And I think it's actually important to distinguish between those latter 2 use cases, because at least in the model where we're using FGCM, right, that gives an internal solution within the Rubin system, and then you can use an external data set like Gaia as a way of validating the uniformity, right? So I think it's important that we actually sort of, think about these 3 different use cases and the methods that we would use for each one.
Yeah. Yes, Colin.
One thing, sort of slightly avoiding the kind of hard questions here, is there something in terms of survey strategy we can do during commissioning that gets us out of the bootstrapping phase faster than we would if we did some sort of naive survey strategy that didn't attempt to address photometric calibration?
I mean, so that's a really good point, and I think that let's start from the hardest question first. Like, for the U-band, if we start where we have existing U-band coverage, even just in the north, with SDSS, I mean, that'll be enough to get that to answer our questions, right? For the initial calibration phase, or with the Vista data, then but it doesn't answer the question of, through the first year, we'll need a slightly more expanded answer. But it's a good point that if in commissioning, our earliest observations are where we have existing U-band data, then that makes our initial life easier. And then we also have, other, GRIZZY data covering it, and can, make sure that our transformations are making sense. It does. Yes. U-band varies. I mean, that's one of the problems. But I'm saying day one, like sanity checks, and then you move out from there. I think it would ease, but it doesn't solve the problem. But it does make our life potentially a bit easier.
And I guess one thing is you need a software pipeline design where you can track the provenance of all these things of like, what, day one, Doug gave us a number and I wrote it down. How does that work? How do we track that? How do we remember that? How do we update that structure? So you need a structure in the pipelines that can handle all these different ways of doing that.
Yeah.
That sounds complicated.
Well, I mean, the way the pipelines are structured right now is you create and ingest a reference catalog. And then when you run, you say, I'm going to use this reference catalog, and it's a configuration thing. So without any modifications to our current pipeline thing, and all that's recorded. Now, additional provenance stuff is being worked on by our talented middleware team. But that stuff is recorded. And so you can have a Pan-STARRS catalog. You could have a Vista catalog that's, with its transformations, and you could have a pseudo whatever catalog that you make and ingest, and you just put it there and you configure and you say, use this. What it doesn't have, what we don't have the ability to say is, based on the position, please use this one instead of that one. I mean, in that case, you would make some uber combined thing potentially that, this Frankenstein's monster of a reference catalog. But that's, just disk space.
But this also comes down to tracking what we did and what we did then, how we redo it and how we compare it, which is the whole not campaign management issue that we haven't totally grappled with. So we know we have to deal with that, which is the other half of the bookkeeping. The micro bookkeeping, as Eli says, is all under control. It's the sort of macro and what do you do next and how do you do the comparisons that still needs work.
And that is where Keith's, Science Cylinders of Excellence commissioning meeting helps.
Catalogs we don't have some
yes
associated with them, and also I think we want to have it LSST then.
Yes. And now, we have the ability. The way the code is structured right now is to take you would ingest a SDSS catalog and then put some color terms. Yeah. For U-band, I don't think that's what we would want to do. I think we would, because of these galactic latitude, kind of effects, especially in the U-band, it may be that, you ingest a specific transformed catalog, because I'd rather do that just operationally than try to write code to dynamically decide it should apply a galactic latitude color correction. But that's all doable.
Speaking of transformed magnitudes, there's a question from John Pareko on the Slack, and it says, has anyone successfully generated LSST filter magnitudes for Gaia DR3 using Gaia X PyTools? He tried it during the Gaia sprint without success.
I have not tried them, and I wouldn't, because it seems that what they've put in there is what they really support. I mean, that was my looking at the code, but maybe Peter has.
So they did not release it with support for D. So I reached out to them, and they don't have it standardized, but they were able to quickly, fastest option to figure that out might just be to reach out to them.
Yeah. Okay, great. Now the standardization is important, though. That's like, yeah. Yeah, so we can be a little patient. We give us a month, as they say.
Gaia have some tools that we could use for that, but I want to remind everyone we have Rubin Sims, and that's what actually Lover used. In Rubin Sims, you give it spectral energy distribution spectrum, it spits out LSST magnitudes. So that's what we all should do within Rubin, so that we all use the same tool, so that we don't have to track provenance of that.
Yeah, that's a good point. I mean, part of this is like how to use the Gaia XP numbers and transform them into our system.
Going back to a question raised by Michael about atmosphere, etc., you used color terms many times. So are we really going to do color terms, or are we going to do it the way we hoped we would have atmospheric throughput from AuxTel, and then we would know?
For bootstrapped calibrations, we aren't relying on AuxTel to give us reduced spectra input into the real-time performance. That's the only place that we use color terms, basically, for the so that's we use color terms, in kind of the real-time and initial analysis when you're transforming the reference catalog to your standard, reference for HSC or whatever. The atmosphere parameters are put in by FGCM when going from air mass X to standard air mass 1.2. Which is and I think that's the right separability, and we'll be discussing this, I'm sure, at Calipalooza. But I don't think we want to go from reference magnitude to air mass 1.5. That's, I think the steps there are in the wrong direction. If that, we want to go everything to the standard. But the point remains that when you observe at higher air mass, that the chromatic transformation and problems that you have in getting to the standard magnitude is more complicated, especially in U-band. But again, for the initial numbers, I don't think we're going to need or have that. I hope we don't need it, because that complicates things incredibly. More questions? Everyone's good. We've solved the problem. I don't think we've solved the problem. This is a tremendous amount of information.
All right, I have a slightly different calibration question. So far we've talked about photometry.
Yes.
But what about the initial astrometric solution, in the sense of when you first go on sky and you hope that the telescope bore sight is pointing where you think it is, but we would like to check this with the WCS. and we can't even do photometric calibration until we have a secure enough astrometric solution to compare to a reference catalog. So this is partly a question that's sort of at the interface of, telescope and data processing and calibration, but just seeing if anyone in the room has input on this.
So I'll give my answer that I gave you before, and now to everyone else. So the Gaia stars for astrometric calibration go significantly deeper than this. So there are plenty of stars. The problem with using Gaia as G-band for HSC has been so many of them have been saturated, and there's challenges in configuration and the mismatch. But if the bore site, if the bore site is good enough, once we've got that fixed, then I think it'll latch on to the astrometric solution pretty damn quick. But the problem that Keith is talking about is from day one, we get the stars in focus, and we haven't gotten that bore site, the pointing model down to where we want it to be, and so we're off by some amount of where we think we are, and does our astrometric solver fall down, and what do we do about that?
Can you hear me?
Sorry.
Oh, John has an answer. Or
Hi. Well, I don't know that I have an answer, but just speaking to that point, if we allow for plenty of extra time for astrometric calibration, take an image and allow for extra time for astrometric fitting, I believe that the solver, if we pad out how much reference catalog we load, I believe that the solver for Gaia can match you even if you're off by a whole detector worth of bore site. If you're off by many degrees, we can't help you.
Okay, that's interesting. I'll let Robert answer.
So the plan is sometime in September this year, actually, to put the star trackers on the TMA, which are reasonably small cameras. I forget the diameter, Giacomo may remember. And we're going to use something like, probably exactly like astrometry.net to sort out where the telescope points. You can swing things around looking at zenith. You can find where the polar axis of the azimuth is. So I think we expect the TMA pointing to be sorted out using that system, wide fields, bright stars, before we put the big camera on.
Or before even ComCam.
Before ComCam goes on. So I think we're going to be in the regime where the solvers we have will lock down.
Okay, that's wonderful news.
Telescope setup problem next month, theoretically.
Okay. Arc seconds, says Robert. So all observatories, of course, all new telescopes have some teething problems here, but Robert says that we have plans for that by latching on these star tracker cameras well before we have anything else attached.
Just to be a little engineering risky about this, if the goal is 3 arc seconds and the requirement is 3 arc minutes, there seems to be plenty of room that totally works. But for the general question of what's integration and test and what's commissioning and what you expect to be...
If this is going to be solved before we put ComCam on, and that's the plan, then hopefully that answers Keith's question and reduces his blood pressure by a little bit.
Star tracker camera. But the idea is that we solve the telescope pointing problem using wide field star trackers, not Eli's problem, maybe my problem or Keith's. And then that is good enough, and we should quantify how good enough is from the astrometric solvers we have, to be able to smoothly go down to the milliarc second sort of levels that I can handle. We can do a pointing mod. Yeah.
One question that I would like to see answered somehow is, and this is still on the astrometry problem, not photometry, is Eli and I have both claimed that Gaia will be fine for LSST because the chips are bigger and the depth is shallower. But I don't think we've actually officially tested that.
So
we can't test it with DC2 because they have a completely fake sky. We could possibly test it on some shallower HSC observations.
So John, to partly answer your question, using Gaia as a reference catalog does work even with HSC, provided you give it the right configs and are careful. I do not like that second statement of being careful. I want to make it more robust to us not being careful. But it actually does work, except for where it does fall down more often is for the edge chips that are only half illuminated.
Yeah,
but I think that for LSST cam that won't be a problem.
Right. Yeah, and I think. Thanks for the reminder. Yeah, like what was it? Like 70% or more of the test run that used Gaia succeeded. So.
And even most of that other 30% can be fixed with configs.
Right. Yeah. Okay. So good.
Yeah. So this is Keith again. Yeah, I would just feel more comfortable and more at ease if we did some testing of this prior to going on Sky with ComCam, just to understand the robustness, how far off the initial estimate can be.
Is Lauren here?
You're basically given a, headers that are just inaccurate.
Yeah.
Right. So it's almost like you're starting off with misinformation initially.
Mm-hmm. I'm going to task Lauren with this at some point.
So I can just say to that I have some dodgy backup code that will do a blind solve against astrometry.net for super early commissioning. If it all goes wrong, we can just say the headers are really bad. We might be off by degrees. We don't fall back to our solver. We submit the coordinates of a bunch of things to astrometry.net and get a solution back. It ain't great, but it's there in case we need it.
Thank you, Merlin. Merlin went through this and more so with AuxTel, where if it was off by more than a chip, then you've got nothing else there.
To Keith's question, I guess I would say that we already have a pretty good feel for how robust the current solver is, which is more robust than the solver we had 3 years ago, because we have DCAM fields that we can now solve that we couldn't previously solve. And it really comes down to how big of a reference catalog are you willing to load, and thus how long are you willing to let the matcher try to find parallelogram trapezoids to match to.
Yeah, I mean,
so,
I think for the initial kind of engineering, I could imagine that we don't necessarily need the solution in real time, but we need to be able to do the processing in a robust enough way that it can inform finding the pointing solution. So it doesn't have to be in seconds, right? But if it's within, that we can have it processed and be able to look at the data the next day, and work with the engineers to fix things, then that seems like a regime that we want to be in.
Okay. Now, also, John, I have seen the current solver fall down.
Yeah. I agree. It can fail, and the cases where it fails are where you are. Well, one of the cases where it fails is when you're too far off, right? If you're off by a degree, we probably can't help you because then the search space is too large.
Yeah.
Pulled up the numbers from the Star Tracker if you're interested. So the RECs that we're going to be testing against are 50 arcseconds RMS without a mount model, so just the raw pointing. That's 50 arcseconds. And 1 arcsecond RMS repeatability. So with a pointing model, I just don't think there's going to be a problem. We're going to be pointing within, say, 10 arcseconds. Our best will be better than that. So those numbers, I think, really retire the need to run a full astrometry net solution across the whole focal plane to say, let me Arcturus off the edge of the field, which would be kind of scary.
Now Merlin is sitting here saying, why didn't you give me one of those star trackers for AuxTel?
Because he didn't ask nicely.
We still want a little experimentation. We want to make sure that we are robust. If we can get Gaia working reliably with HSC, then I'm very confident that we can get it working with ComCam and beyond. And now you say we should fudge up the headers so they're 20 arc seconds off, and if it's robust to that, then we're good.
The HSC chips are also less than half the size.
That's what I'm saying. That's why this is the saturation level and the chip size. So if we can do that, then I think we're guaranteed to be able to work.
Can I go back to photometry?
Yes, please. That's what
So
the title of the session is.
I know. And then the questions are for you instead of me. So you talked about this Frankenstein photometric catalog, and that has me really worried because we don't have, I mean, you touched on this, but we don't have any facility for choosing how to apply color term or whatever kinds of corrections when you don't actually know whether this source in the reference, whether a source in the reference catalog came from Gaia or DES or whatever.
The Frankenstein's monster reference catalog that I'm envisioning is not like that. It is something that you would say you can't do that.
Yes. Okay.
It would be a specific combination where color terms have been pre-applied that is meant for LSST prompt processing and commissioning or the first year or something like that.
Okay, yeah. So that's what I was going to say. Like, you have to bake in all of the corrections in advance. Who is responsible for generating that monster? And that's not, I don't think that's a question for you, Eli. I think that's a question for Robert or someone else in the room.
Then you don't want to hear my answer, which was John Pareka.
Nope, it's not my responsibility.
Yeah, it's my responsibility for making sure that work gets done, and then Yusra's responsibility for assigning the work out, I think. If that's the direction that we decide to go.
This question and answers motivate the following question. Are you going to have any help from international collaborators or any other team external to the project during commissioning? Or is it just you and other DM people?
I'm looking at Keith here.
Yeah, so the current thinking, this was discussed a bit on Tuesday at the science verification validation session, is that we would set up what we've been calling science units that are focused on different areas of the science performance of the observatory during commissioning. And we're envisioning to have one of these science units that is devoted to photometric calibration. And I could imagine that this is the right place to bring in groups from across, DM science pipelines, operations V&V, systems engineering and commissioning, also the international contributors, US, Chile, in-kind contributors. The point, one of the goals of this structure was to try to avoid questions about how people are getting involved and then get them focused on the specific science topics of interest. And so I think this is an area where we have a couple different in-kind contribution groups that have relevant background and expertise. I see several people in the room right here that I'm thinking of. So I think Eli will not be doing this alone, right? Eli will have a team around him.
And then one question I have is when do those commissioning groups get rolling compared to the start of commissioning?
We would like to stand these up in something like the next month or two.
Okay.
Yeah.
I hope that answers your question, Jelko. So we've been here for an hour. We have 30 more minutes, and we could reclaim our lives, or Jelko has more questions.
Suggestion. So given that there are no other questions, going back to that Frankenstein catalog. So ideally, and now people who disagree can shout at me, but ideally, what one would want to know is first list of all the stars in our survey area, And there we could just take every single catalog that exists and make a union of all the stellar objects.
Mm-hmm.
And then the next thing is we would like to know what's log G, effective temperature and metallicity for each of these stars. And that would allow you then to take stellar models and produce photometry at 1-2% level for any band you want, for any air mass you want, for any atmosphere you want. You just do simple integral and you get your flux, your magnitude. So the key... Right,
yeah.
and extinction if you go close to the plane. So
Anywhere.
basically what you would like to do is to start with some reasonable priors for these quantities. And then as you throw in more data, more surveys, sometimes even spectra, you just get narrower and narrower posterior PDF. So now there is a star on the sky, and you observe it in commissioning, and then I go to this database at that star. I look at what is the posterior for log G, flux, metallicity, etc. And I pick up correct Kuruch or any other model and run our Rubin Sim integrator, and it spits out LSST magnitude.
So that's a really good point, and I would, just operationally, I would think about it as, okay, there would be a standalone task that would suck in all the catalogs and these parameters and Gaia and all of this and spit out a LSST calibrated Frankenstein's monster catalog. And then that can be updated as you get more data, and that, in a couple months you would have a better one that you could then do. Now, you're talking about also as a function of air mass. I think we should talk more about that if that's really that complicates how you do things in real time. And I don't want to be doing all these integrals, for alert processing if we can avoid it. And I'm not sure that it's necessary, but to have the synthetic spectra and integrate them out, as doing a better synthesis of what we know than just the simple union, that makes a lot of sense, especially for the U-band, where we do have to synthesize that for a lot of stars. And there will be a lot of work for this photometric calibration commissioning team to validate that Frankenstein's monster catalog actually makes sense in a uniformity, that you don't suddenly go a couple degrees over and get a completely different solution, because that would make us unhappy.
So marginally relevant to that, Keith points out that we would like to start people working in the next couple of months, month or so. And one thing we certainly asked them to do is to think about what precursor data they can do that on. So if we built a Franken catalog, we would want to validate it against the HSC data we already have.
Yeah.
So we can do that now. We don't have to wait for ComCam to go on the sky. And we've been.
Oh yeah, no, this is all stuff that can be happening now and should be starting now.
Right. So think precursor data until ComCam turns on, and then run the same codes against ComCam, and there will be no problems.
All right. Any other questions from the external participants? Okay. I think we have accomplished something here. Thank you so much. Enjoy your extra 25 minutes before they bring out the cookies. And have a pleasant afternoon.